Right now, people, now suppose when an observer like this, okay, observe something happening. This way. Suppose this observer is A. Now, A sees in a particular way of happening that. A sees the way of happening this. Once he explained the experience, the way he saw this, people, we define as relative to this A. Relative to this A, the thing happened. Okay. The experience this observer A gets, he explains. Now that is known as the relative to A. Relative to A, the observation. Okay. Now, when this observer A is at rest on the earth, the way this observer A can see about the same happening, and people, when this A is moving with particular velocity, while he is moving with a particular velocity, once he observes the same thing happening, the way he sees is different from the first. Understand? When he is at rest, he observes this incident. Secondly, he is moving with particular velocity and he observes the incident. In these both cases, people, the way he sees it different. Okay. So that is why, people, we have to very carefully study the observation. The observation is different once the observer is moving and observer is at rest. Now, again, when this A moves and then he observes the same thing in a different way, A can observe that. There also we define, people, the observation A sees. Once he explains, we say that is relative to A. Relative to A. Okay? Relative to the observation A. Right. Now, here to understand this further, now suppose here, when somebody is inside the bus, right here, suppose A, then bus is moving with, suppose, 10 meters per second forward this way. Another observer on the earth resting, suppose this observer is B. Now this observer can see this person, capital A, is moving with the bus to the rightward direction with 10 meters per second. So that is the actual happening there. Okay, right. So then it is written, V is the observer now. Velocity of this A relative to B. This is how we write. Then second letter is always, people, this observer. He is the one explains this. His experience only, now we are writing here. The observer B can see A is moving with 10 meters per second rightward direction. Okay. Then it is written as velocity of A relative to B. The second letter is always the observer. His experience only, the way he sees only, we write here. Then this people, velocity of A relative to B is 10 meters per second, it is the velocity of the bus. Right. Now, people, meantime, we ask from this A, the way you can see about this B. Now, people, you know, when you move in a bus, it's very obvious thing. No? When you move in a bus, people, you can see the outside objects are going back, and they are inside the bus. You think that you are at rest. Then you can see the outside objects in the outside objects in the environment going back. Then A can see B is moving backward direction this way. The same velocity, 10 meters per second, you can see. Then you can get a feeling, people, actually you know that you are moving in the bus. But at the instant, you watch the outside things, the motion of the outside things, people, there you realize the things are going back. But you know, definitely, I am the one who moves forward. But for a short time, you assume that you are at rest and the things are going back. People, this is the important concept in this relative velocity. Then remember always, the observer, while he is observing something, he assumes that he is at rest. Having that intention only, people, he explains everything. Otherwise, people, when somebody is moving in the bus, right, we know that we are moving forward, but we see the outside objects are going back. That moment we think we are at rest. Because of that concept only, we actually verify that objects are going backward. So therefore, the very first concept here you must understand is, people, this one I said in the relative acceleration lesson also, right? When observer observes something and get particular experience means the way he can see the things happening. He always get in them with the intention that he is at rest. Assuming that he is at rest, he analyzes everything. The good example for this to understand is, people, the story this: when you move in a bus, the objects outside going back. So that is the first thing you must understand, right? And we proved in the relative acceleration lesson the principle of relative velocity and principle of relative acceleration. So then I am not going to prove them again here. Then the principle of relative velocity we use here. Okay, right? Then when I write the principle of relative velocity regarding three objects, right? Now suppose when we have three objects like this, A, B, C, moving with different velocities like this, then suppose velocity of A relative to B, we need to find. This B is the observer. Then this one we can write, people. This A and B we put to the right hand side beginning and the end like this. Then the third object going to be C. That C we put in between them like this. Okay. Then we add. See here, the middle letters being equal. The right hand side first and last going to be left hand side, the two in that order. This is, people, the principle of relative velocity. Here you know these velocities mean, people, vectors. This is a vector, this is a vector. Understand? Then here we are going to add two vectors. We are going to add two vectors. Adding two vectors is very similar to say, people, when we consider forces, forces are also vectors. when we add two forces mean people, we are really adding two vectors. We learned under vector lesson, addition of two vectors mean people. We are going to find out the resultant vector for the two vectors. If the two vectors are the forces, by adding these two forces mean people, there we are supposed to find the resultant force of that two forces. Like that, people, in this case, we add two velocities. Then here we are supposed to find the resultant velocity of these two velocities. That is the meaning of adding these two velocities. Now, the other thing is, when we add these two vectors, people, we use what? The triangle law of vector addition. Triangle law of vector addition. Triangle law of vector addition. Right? Now, this is a vector. We first represent this vector by a side of a triangle like this. And this is also a vector. It's a velocity in a vector. We denote that by another side of the same triangle. Then we need to add them up. Then we use what? The triangle of vector addition. How? The two vectors to be added are represented by the adjacent sides of a triangle in magnitude and direction. Then their sum is given by the third side like this. Then this is the finally answer of this. Velocity of A relative to B. You can remember in relative acceleration lesson, we didn't construct this way a triangle to find out the resultant acceleration. That is because of, you can remember, in that lesson, we applied F3 plus MA in different directions. Though people, we find this way a resultant acceleration by using the triangle law of vector addition, whenever we apply F equals MA along different directions, people, we have to take the component of this resultant acceleration. Rather than taking the resultant acceleration, using its initial two components and taking their resolved parts along the direction we apply F equals MA is much easier than considering this way the resultant acceleration. So that is why in that lesson, by drawing this way a triangle, we didn't draw what? A triangle, we didn't draw for in finding what the resultant acceleration. But in this case, we don't apply that way F equals MA. The object is really moving in the direction of the resultant velocity. Now, for example, people, suppose when something flying like this, now we give a velocity to that object, this direction. It is moving horizontally. Away from us, we give a velocity. Then it had earlier this way velocity, and soon after giving this way another velocity, the object which was flying now has two velocities. One is this direction, other one is perpendicular there. Then the object is moving, people, with the resultant velocity of that two velocities. Okay. Then it was moving like this and given a velocity like this. Now it is moving towards you like this. Understand? So that resultant velocity only, people, we are going to find out by this, applying this principle of relative velocity. Okay. So therefore, here you have to first understand velocity of something relative to another observer mean the observer can see in a particular way this occurrence. That is the meaning of that. In explaining the occurring thing by the observer, observer always assume that he is at rest. Having that idea in his mind only, he explained that thing occurring. That is very obvious. The story in the bus, you can take that as an example. Okay, he assumes, he have the idea that he is at rest. Having that in his mind only, he explains everything. Right. Those concepts are very important in understanding this lesson. Right. Now, suppose this way. Now, people, when I consider in the OXY plane, suppose this is our y-axis, this is our x-axis, this is origin. Right. Now, suppose a particle A moves on this plane, and here at the point O, there is another observer B. B is at the origin O at rest. Right. So now when I join this OA line and when I put the arrow towards A this way, people, what is meant by this OA? OA vector. It is position vector. Vector of A relative to B or relative to O. O and B at the same position. Position vector of A relative to O. People, what is meant by position vector? Yeah, it is really this, no? What are the things available in this? O to A distance available in this. O to A direction available in this. So therefore, people, distance plus direction together give us displacement. So therefore, this is nothing but displacement of A relative to O. Okay. Now, people, if I consider this particle A is moving, then you can very clearly understand when the particle A is moving along a path like this, from time to time, the displacement changes. When the displacement changes, we can find the rate of change in the displacement. People, you know, rate of change in displacement is the velocity. Then we can find, people, the velocity of this A relative to this O. Understand? Then to find that, I can differentiate this d upon dt OA. Okay. Right? This is nothing but rate of change of displacement of A relative to O. This one we differentiate. You know the meaning of derivative. D upon dt mean, people, in 1 second, the change of the displacement. In 1 second, the change of displacement mean, people, the velocity. Then by differentiating this right hand side, we get rate of change of the displacement of A relative to O. Relative to O. Okay, that means velocity of A relative to O. This is nothing but velocity of A relative to O. This is how we write. Why do you use the word they are relative to O? Because this displacement here we have of A relative to O. That's the reason. Okay, so then I can write d upon dt OA is people velocity of A relative to O. Okay. Now I can write people this OA vector like this. OA vector I can write minus AO. Correct? No? When I interchange the order of these letters, under the vector lesson we learned extra minus sign coming out. Then I can write this as minus AO. And now I differentiate that. Okay. Then this minus sign you can take out. Minus d upon dt AO. Okay. Then you can see here, this minus sign you can put here. Now we have d upon dt AO. Look at this. D upon dt OA velocity. What is this letter? The second one here. What is the second letter on the right hand side? The first one here. Like that, now you can write this one. How? Velocity here. The second letter on the left hand side, only the right hand side first after V we have. Then here we have to have O. And then people, the first one come in this way. What is this? Minus velocity of O relative to A. Understand? Right? So then by combining these two together, we can write people one relation. When you differentiate OA vector with respect to time t, we get this. So then I can write people this way. Then now this is this way we have. Now you can write people, but you can write OA vector is equal to minus AO. This is well obvious fact. Right now? Then you can write differentiating this both. D upon dt OA is equal to d upon dt minus AO. What are these people? This answer. V A comma O. What is this answer? Minus V O comma A. By this relation, people, what do you understand? By this relation, you get the idea that people, when you interchange these places of the letters, okay, these two have been interchanged on the right hand side here. O came first, A secondly. Once you interchange this, extra minus sign coming out. Understand? That's what you must understand by this. That means when we have something like this, velocity of A relative to B, now I am going to interchange these letters. V, B comma A. Once you interchange these letters, people, extra minus sign coming out. You must understand that by this illustration. Understand? Okay? That is the next one you must understand. Right? That means here B is the observer. Velocity of A relative to B is minus velocity of B relative to A. That's true now, people. Now, when you move in a bus, the stationary person on the earth, you can see going backward. But that stationary person observes your motion, then he sees you are going forward. Correct now, people. The directions opposite. this minus sign says the direction opposite. That's what this says. If A here, you suppose you're moving in the bus, B is the outside person. Now B notices that you are going forward. Now here you are the observer. Now you observe about this B. You can see his direction is opposite. Okay, that's what this result people says us. Therefore, another important one is this: when we interchange the places of these letters, extra minus sign coming out. Okay, right. So those things only people at the very beginning you must understand. Right? Okay. Right. Next thing people this we'll see. Up to here, I think you have a particular idea, right? Now I am going to take another one example. Right. Now suppose a person, capital A, is moving this way with velocity, suppose 4 meters per second, right? That is the east direction, right? East. Right. Now somewhere here, another person B moving north direction like this with 3 meters per second. This direction is north. Right. Now you have this experience. Now you are now moving forward direction. In front of you, somebody crossing you. Now both are moving. Now the way you can see the motion of that guy. Now I am going to consider that. I need to find velocity. Now here is suppose u. Now the way you can see about this b, that means velocity of b relative to a. A is the observer, u. This is what we need to find. Then what are these two velocities? These two velocities are the velocities of a and b relative to earth. Then we know velocity of a relative to earth is people this direction, 4 meters per second. Velocity of b relative to earth, this direction, 3, north direction. Right. Now when I need to find this velocity of b relative to a, I have to apply principle of relative velocity. How to apply that now, people? Velocity of b relative to a. I'll try this now. Velocity. This BA letters we have to put on the right hand side, beginning and end. To the right hand side, to middle, we have to put this third object. What is the third object? Is the earth. A, B, and earth are the three objects. Right. Now we are going to use the principle of relative velocity. People, very carefully understand, whenever you use the principle of relative velocity in this lesson, soon after writing like this, principle of relative velocity, you know, here we are supposed to add two velocities, no? Velocities means vectors. Addition of two vectors only, this time we are going to consider. You know, addition of two vectors is done how, people? When we have this be a vector, this be a vector, when we need to add them up, people, what is the method? We have to represent these two vectors which are to be added by the two adjacent sides of a triangle like this. Then we construct the triangle. By the third side of the triangle, we get what the vector sum. They are this vector when we represent by PQ, this vector by QR, then we get what? PQ vector plus QR vector is equal to PR vector. Understand? Like that, people. First, for this, you have to put a vector, suppose PQ. then you know from the ending point of the first vector only the second vector starts. Then second vector we must write starting from this QR. Then other one you know here PQ, QR. The answer is what? First point and the last point, PR. Like that, the sum of the two vectors is given by PR. This way you must definitely write as your second step. Understand? Right. Even now, third step is this. BE. What is BE? BE. Due north, direction 3. Then that is represented this BE vector. What is this vector? Velocity of B relative to Earth. It is represented by PQ. BE people due north 3. Then we have to draw this way. Arrow should be pointing upward. This vector is pointing upward, no 3 units. That vector is given by PQ. Arrowhead is this direction. Then where should be the point P? When we move from P to Q, the arrowhead should be pointing upward direction. Therefore, this point should be P, this point should be Q. Right. Now people plus QR. By this QR, we supposed to represent this vector. EE. People, we have AE. AE. Here, rightward. Rightward 4. But here we need what people? EA. People, how to write it? EA. EA is nothing but minus AE. No, just now we proved this. No. Then you can very clearly understand minus AE, rightward. Minus rightward means people leftward. Minus rightward means leftward. So therefore, people, what is this? This is leftward what? 4. This is leftward 4. Arrowhead pointing leftward 4. But this vector only people represented by QR. In vectors, you know people, when we write like this a vector AB, arrowhead going from A to B. Then how to write this as AB vector. Then A to B order. See the order of the letters from A to B. A to B. Then the arrowhead is pointing from A to B. Now we know this vector is pointing this way, but it is given by QR. Then people, you can very easily determine where should be the point Q and where should be the point R. When you move from Q to R, the arrowhead should be going to there. Then Q should be here, R should be here. Understand? Now people, the two sides of the triangle now we have. Now we have to draw the triangle. Now we have to draw the triangle. Now we have to draw that triangle, right? Now when we draw that triangle, people, very easy. PQ is this way. PQ, it is given as 3, no? 3. And from the ending point of Q, this QR starts on this way. This R, this is 4. Now the two sides of the triangle we have is now 90. Now we P and R we have to join like this. Now people, by PR, what do you get? Velocity of B relative to A. Velocity of B relative to A. Now, by the length of P to R, what do you get? The size of the velocity. The direction from P to R, we get direction of the velocity of B relative to A. Therefore, by using your trigonometry knowledge, Pythagoras theorem knowledge, or any other geometric knowledge, now our purpose is to find out this PR length and its direction. That's all. So now I can write this angle as theta. If this is theta, if I draw here, this is also theta by alternate angles. Then you can write this tan theta. Tan theta is 3/4. Then theta is tan inverse 3/4. And PR length you can now write, people, by using the Pythagoras theorem. By using Pythagoras theorem, right? By using Pythagoras theorem, when you write PR length going to be 3 squared plus 4 squared root. This is people 5. Then you know, therefore, the velocity of B relative to A, right? This direction, making this angle with the horizontal, that means in the direction of east, theta, side is 5. Okay. This is what you can see. They will actually, this feeling we get. Now, when you move in a vehicle, suppose a little distance in front of you, somebody is crossing the road. Then when you very carefully analyze, when you have a particular bigger velocity, people, right, you can see the passenger or the person in front of you really crossing the road perpendicular to the edge of the road. But when you are moving with a particular fast velocity, people, you can see really that passenger is crossing the road not perpendicular to the edge. You can see he is coming towards us this way in an angled, what means inclined path. That experience we can very clearly see when you move in a vehicle with a considerable velocity. Understand? Okay, with a considerable velocity mean, people, right? So when your velocity is, people, high velocity, you can see this inclined path. Otherwise, the inclined path occur in there, but that can't be recognized because it is a very small angle. So this is really happening there. And remember, this relative velocity lesson is not assumed, right? Not an assumed situation. This is really happening. This is really happening. Okay, right. Now, the other thing is, if I need to find the other way around, what? Velocity of A relative to B. This one we found. Now, the other way around, we need to find velocity of A relative to B. This is, people, nothing but, we can try this one, minus B, B comma A. We interchange these letters, then extra minus sign coming. Then we can write this one as how? Minus B, B comma A is this, no? Right? Minus this means the direction gets opposite. So therefore, this is this way now. Understand? With the same velocity, the direction only gets changed. Right? So this only, people, you have to understand whenever you follow or use this principle of relative velocity. These steps don't miss, people. First one, write the principle of relative velocity and substitute for the velocities this vectors this way. When you write the vectors also, PQ, and the second letter must be first in the second vector, and QR. Then the left hand side are also going to be first and the last letters. They together give the left hand side. Understand? Then we correctly apply that vectors here, and we construct the triangle. Finally, by using the triangle, if it is a right angle one, by using the Pythagoras theorem, you can write the length. If it is not the right angle one, sometimes we have to use the sine rule, cosine rule, and trigonometric method. Right? Using them, one of them, people, we have to find the length of the relevant side and the direction of the relevant side. If you can manage these, people, this is all the reason. Sometimes, now here, as I explained, Here we found the velocity of B relative to A, this one. Then that we get this way. That means this A, while he is moving, B also moving. When this A going forward, people, this A can see really this B is coming along a path like this. Along a path like this. That actually, people, we can see. That actually we can see. When you very carefully observe this, you can see that. Right? When you consider this way, person is crossing the road perpendicular. You are coming from this end. When your speed is little bit fast, people, you while moving, you can see this one is crossing this way. This experience you can very clearly see, get. Understand? So therefore, don't think that this is an assumed situation. This is not really happening. So therefore, until we get the answer only, we have to adopt that theory. Thereafter, that is not really happening in our real life. Not because this is really happening in real life. Understand? So therefore, accept these things as correct. Then of course, we have a good confidence. Then you will apply anything without any doubtful nature in your mind. Due to that, people, this lesson will be a very easy one. If you keep like this, no, this is not happening in our real life. And this is a particular thing until we do the question. Then if you take like that, people, you want to absorb the next complicated theories available in the lesson. And due to that, of course, this lesson will be not a that lesson will be a doubtful one. Doubtful one means what? No, theories are false, wrong. But since we need to work out the question, we have to accept that. That kind of nature, when you give to your mind, people, brain, that brain will not give you the output, the efficient output, effective output. These things, people, really happening. Really happening. Understand? Okay. So the best example is when you move in a bus, the outside of it going back. That experience will get people. The way you see. Here also, the way you see about this one is this. Very carefully, you can see that. But there, people, this velocity, your velocity should be a little bit greater value in order to see this inclined path. Otherwise, you can't, that inclined path is occurring, but you can't catch that easily. Okay, right. Now, people, now we have to first break down these notes. So then I give the summary of this setting. If you need more data from this, get the recording and the important places you find, you can take down the separate note. But I am going to give you the summary of this. If somebody get this summary by copying your notebook, people, this said the idea by explaining this way during 1 hour nearly, he won't get that. By the summary I gave you. Then anybody, if he or she need to get this idea, he or she must watch this recording. Otherwise, this one won't get by the note I am going to give you. Okay, right. Then people will take down this form, right? Then write the heading as relative velocity. Write down like this. Write down like this. Suppose two men, A and B, move. Suppose two men A and B move. Now write down. When capital A observes the motion of B, when capital A observes the motion of capital B, the way capital A sees capital A sees is called as the motion of capital B the motion of capital B relative to capital A. In this case, the observer is capital A and when capital A explains the motion of capital B, capital A assumes that he is at rest. That he is at rest. Write down in this way, the velocity of B the velocity of B the velocity of B observed by A is called as velocity of B relative to A. And it is written as V B comma A. VB comma A. What is then the meaning of VB comma A? Velocity of B relative to A. A is the observer, right? A is the observer. A is the observer. A is the observer. Right. Write down, people. Note that V A comma B. What is this? Velocity of A relative to B is what? Minus V B comma A. This we proved, people, no? Therefore, I'm not going to prove. If somebody needs this in detail, watch the recording as I illustrated on the board and take down that note. Okay. Yeah. Okay, now write down, people, next subheading like this. Write down principle of relative velocity. 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 We'll write like this. Write down like this. Consider three objects capital A, B, and C move. Then V A comma B we can write, people, how this A and B come in first and last on the right hand side. And the third one coming in the middle like this. This is the principle of relative velocity. We proved this in the relative acceleration lesson, so therefore I'm not going to prove that again. After differentiating this only with respect to time t, we obtain the principle of relative acceleration. Right. Now let's see how to use this principle of relative velocity to find the velocity of something relative to another. Right. We'll come to one example. Velocity of A relative to Earth, east direction 3 units. Velocity of B relative to Earth, north direction 4 units. Find velocity of A comma B and velocity of B comma A. The example we did. Right, people start. Right, now when we write here, V A comma B is equal to V A comma E plus V E comma B. Right. So now what is the second one? Put here a vector PQ, and the second vector you must start from this Q. You know the reason for this, QR. Then the left hand side vector is given by PR. This is really coming by the triangle law of vector addition. You know that. Now A comma E. Yeah, A comma E is right toward 3. This one, A comma E, given by PQ, right toward direction 3 units. PQ. Right. E comma B, people. E comma B, but B comma E only we have. I can write this as minus interchange this order. VB comma E. This whole thing only people represented by QR. Now you can very clearly understand B comma E, B comma E, right? B comma E, upward direction. Okay. Then here, this is upward direction. But before that, we have minus sign. Minus upward direction means people downward direction. This only people are represented by this QR. According to the vector notation people, if this is represented by QR, when we move from Q to R, to that direction only this arrowhead should be pointing. Then Q should be here. R should be here. Understand? But this size we know B comma E 4. This way. Here 3, P, Q. Now the two sides of the triangle we have. Now we have to combine them together to form the triangle like this. Okay. This way. P, Q, R. Here 90. This is 3. This is 4. Then PR is here. Left hand side also PR. P to R here. Order of the letters P to R. P to R. Then arrowhead should be pointing like this. Very easy. Right. Now we draw the triangle. This is known as people velocity triangle. In the questions, you are given draw the velocity triangles. Then this is you have to, this is the one you have to draw. Right. Now the length of this PR, you get magnitude of the velocity of this A relative to B. By the direction from P to R, we get the direction of the velocity of A relative to B. Okay. Then let us take this angle as theta. Okay. Right. Now we can find PR by Pythagoras theorem. Pythagorean theorem. We can write PR squared is equal to 3 squared plus 4 squared. Then PR is the root of this. That is nothing but 5 meters per second, right? Units not given, but we'll keep like this. Right. Theta, you can write by tan theta, 4 by 3. Theta, tan inverse 4 by 3. Therefore, velocity of A relative to B is this way. 5 units. The angle is theta. Theta equals tan inverse 4 by 3. Then velocity of B relative to A can also be found by this. You can now write that like this. But since velocity of B relative to A is equal to minus velocity of A relative to B, when we exchange these letters, their positions, minus sign coming. We must have minus BA comma B. A comma B we found this way. 5 with this angle theta. But having minus sign. Because of this minus sign, this arrowhead get opposite. That means this it should be like this. This way 5. This angle theta, I mark here. Theta is tan inverse 4 by 3. 4 by 3. Right? This is how we take that. Okay. Right. We take another one, people. We'll take another one question. Take this. Velocity of A relative to Earth. Second question now. Velocity of A relative to Earth is this way. People, 3. Okay. Velocity of B relative to Earth is 5. No direction given. No direction given. And furthermore, we are given velocity of A relative to B this way upwards. This way upwards. Upwards means due north. Suppose when we consider this way the 4 major directions: north, east, south, west. Then this A moves to east. Velocity of A relative to B, north direction. Velocity of B relative to Earth, 5 units, direction is not given. Then people, there are 2 questions. First question is the direction of this B relative to Earth. We know the size only, direction unknown. That is one unknown to find here. Secondly, size of the velocity of A relative to B. Direction is known, the velocity is unknown, size is unknown. There are 2 things. Right, people, now in this case, first we have to study the question. Question is regarding 3 velocities. Out of the 3 velocities, there is only one velocity. Its magnitude and direction both are given. Another one velocity, only magnitude, no direction. Other velocity, only direction, no magnitude. Given these 3 velocities, asking 2 questions. The direction of the velocity, only the magnitude known. The magnitude of the velocity, only the direction is known. 2 unknowns are there. People, remember in this case, we have to use the principle of relative velocity to find these unknowns. When you write the principle of relative velocity, people, you have to always subject the velocity this. This means the velocity whose direction only we know. This one you have subject. This one you have subject. Understand? By subjecting this one, we have to always write the principle of relative velocity. Remember that one. I'll tell you the method or the reason why should we do this. Yeah, then I am going to write by the principle of relative velocity. We can write velocity of A relative to B is equal to V A comma E plus V E comma B. Then people, as before, we write here PQ vector, QR vector, and this is PR vector. Right. Now PQ vector, A comma E, write 23 like this. Hmm? 3 units. Given by PQ. Okay. People, E comma B given by QR. But to draw a line here, the direction of E comma B we don't know, because B comma E given as 5 without a direction. If the direction is given, by taking the opposite direction, we can get the direction of this A comma B. But since the direction is here unknown, we can't draw really what people? A line segment showing its exact direction. That occasion, what we do is this. This velocity is represented by QR. Okay. Then here we write plus. Size is 5, no? 5. Right? Represented by QR. QR vector like this, we write. And the left-hand side, PR. Velocity of A relative to B. Velocity of A relative to B, direction is known. And then, since we know the direction, we write direction like this. Here P, here R. Okay, up to here, I think you can very easily manage. Now, people, this is what we do. To the right-hand side, what is the common letter? This is PQ, this is QR. Common letter for these two vectors is Q. Correct, no? This is PQ, this is QR. Common letter is Q. Where is Q? Here we have Q. Now what we do is this. Taking this Q as center. Always the common letter only we consider as our center. Taking the common letter on the right hand side as the center, we draw a circle whose radius is this much, this one. Understand? Always the common letter on the right hand side, we take as a center. Taking that common letter as a center, we draw a circle whose radius is this 5. Okay, that's the method. Right? Then I am drawing that. This is a circle of the circle, people. The center is Q. Right. Center is, remember, always the common letter on the right hand side. Now, radius is 5. The radius is 5. Now, PQ 3 units. Therefore, P should be somewhere here. Radius is 5. PQ is 3 units. Here P. Right. This is Q. Right. Now, people, Since the radius of this circle is 5 units, from this Q to any point on the circumference, from this point Q to any point on the circumference, this length is 5 units. From this Q to any point on the circumference, the length is 5 units because the radius of the circle is 5. That is why I say like that. But you know, this QR vector also 5 units. QR length should be 5 units. Then you can very easily say the point R should lie where? On the circle. The reason? QR length should be 5 units. Q is here. The radius of the circle is 5. Therefore, point R should lie on the circumference of the circle. But point R should be on the circle so that when we join that P and R, PR points upwards. Then the easiest way of finding the location of point R on the circle is, people, from the point P, we draw vertical line like this until that cuts the circle like this. Then this is the point R. Then see, point R should be on the circle, that is okay. And when we join this P and R, PR should be pointing upwards. That also okay in this case. Here, P to R, PR should be pointing upwards. Then the point R should be on the circle here. Then here, people, we drew what? The velocity triangle. Then PQ here, 3 units. QR, Q to R, here, people, Q to R, this, right? Q to R, this is 5 units. Right? Oh, RQ also we can take, right? We don't, we have QR, no? Yeah, we will take QR, right? Let's see. Now this is 90. Okay. Now, people, this PR length can be found by using the Pythagoras theorem. PR length can be found by using the Pythagoras theorem. And this is circle, right? PR length can be found by using the Pythagoras theorem, right? PR length. PR length is 5 squared minus 3 squared root, no? It is really 4. People, therefore, what is PR? PR gives A comma B. Then we can write the velocity of A relative to B. What? Velocity of A relative to B should be given by this PR. PR pointing upwards. Here, P to R pointing upwards. With size, this is just now we found 4. First one is okay. Second one, people, we need to find direction of velocity of B relative to Earth. People, what is this? E comma B. I am going to find this angle as theta, see? Then tell me what is cos theta by the diagram. Cos theta 3 by 5 theta cos inverse 3 by 5, right? You can very clearly see here this velocity only represented by QR in the diagram. This velocity only represented by QR in the diagram. Then you can write like this: V E comma B, here represented by QR. Right. People, I am going to change these letters. B comma E. We get minus sign before. Then this is QR. Then we multiply both sides by minus sign. We get minus QR. People, minus QR means what? RQ, no? RQ. Then velocity of B relative to Earth is given by RQ. RQ. We need the direction RQ. RQ means this way. Yeah, therefore, RQ is this here. 5. This is the velocity of B relative to Earth. What is the angle? Theta this. The direction should be opposite like this. Then we know what the direction of this B relative to Earth. 5 units making an angle theta given by this. Understand? So therefore, theta equals cos inverse 3 by 5. Understand, people? Understand? Right? So this is how we use the circle to draw the what? Velocity triangle. Understood? So therefore, whenever you need to draw a circle, people, that comes under 3 velocities anyhow we should be given. One velocity contains in both magnitude and direction. Another one velocity only direction. Another one only magnitude. In that case only, people, we need to draw the circle. In drawing the circle, what is the method? The velocity having only the direction should always be subjected. Other two should come to the right hand side. Then on the right hand side, there are 2 velocities. One, we have both magnitude and direction. Then we have to draw the circle how? Taking the common point to the right hand side as a center. And its radius is what, people? The velocity of the unknown direction. The size of the velocity of the unknown direction. Then draw the circle. That is how we prepare the circle, people. Okay? Right. Now, we can come to another one question here. Okay. We can come to another one question, people. Take the next question like this. I'll take this way, it's U. This has V, right? Velocity of V comma A, downward, okay? Right? Find, we'll write this. For the cases V greater than U and V less than U. Find the direction of V comma E and the magnitude V comma E. Right? This is the question. Right, I'll give 2 minutes, people. Just try this. First, I am going to consider, people, the case V greater than U. First case is this. V greater than U case. First case is this, right? Then we have to subject this, no, the velocity which has the only direction that we have to subject. Then it is v comma e plus v e comma a is a. Okay. This is denoted by people PQ vector. This is by QR vector. Therefore, this is by PR vector. V comma E people, here V. That is denoted by V size PQ is the vector. Right. E comma A only we need. A comma E rightward. Then E comma A should be, A comma E should be leftward. Right? Leftward U. That is represented by QR. Q to R. When you move from Q to R, the direction of the arrowhead we must get. The direction of the arrowhead is left. Then our Q should be here, our R should be here. Right. PR, B comma A, downward. Here P, here R. Then, people, to the right hand side, common letter is Q. Then we have to draw a circle with Q as a center. This way. Q. Then it's where what people radius is V. QR this way. R is here. It's U. QR, U. But V greater than U, no. V is the radius of a circle. Then U smaller than V mean the diagram is correct like that. Okay. Now the point P we need. People, PQ vector has a size V. The radius of the circle also V. The distance from Q to P should be V. That's the meaning of this PQ vector size V. Then you can very easily understand the point P should lie on the circle. Now we have to find out the exact position of the point P on the circle so that P and R when we join, that should be pointing downward. So therefore, when I draw this way, people, vertical line when I draw through the point R, that cut a circle somewhere. This is the point P D. Right? In PR points downward. Then we can join this P and Q like this. Then this velocity Q, PQ I take. This PQ is now V. Then you can write, people, PR. You can write by using the Pythagoras theorem, square root of V squared minus U squared. And I am going to take alpha now, then cos alpha. Cos alpha, adjacent divided by the hypotenuse. Then alpha, cos inverse U upon V. Then you can answer both, right? This is alpha. This is alpha, right? Then you can write the first one. velocity of B relative to A, its size we need. It is downward given by PR. No, PR is this square root of U squared minus U squared. And next one, the direction BE. BE given by people PQ. PQ is this. Velocity of B relative to Earth. This V. V. This angle is alpha. Alpha is cos inverse U upon V. Right. That's the first case, V greater than U. Right. Second case, V less than U. Right. Second case, V less than U, number 2. V less than U. V less than U mean, people, V is the radius of the circle, no? The radius of the circle should be less than this U. Then when you draw the circle with the center Q, the circle should be like this. Right? This is a circle. I draw that circle, separate it like this. I erase this now. Now circle is this. Center Q. Now QR is this. QR is U. Now U greater than V. V is the radius. Therefore, this QR line segment, its length should be greater than the radius. Then point R comes out of the circle. And still the point P should be on the circle. Point P, because PQ length, PQ length should be given this V, no? Right. Then the point P should be on the circle. Now we have to find the location of the point P on the circle when we join for the point P on the circle. When we join that location and this R, the corresponding line will be pointing downward. No location for the point P on the circle. When we join P and R, the line segment is downward. Understand? So therefore we say what? Subject to the case V less than U, we can't find the unknowns. Such unknowns cannot be found in the case V less than U. Understood? That is how we summarize the situation. Right? Then this diagram we have to erase. Then we get people this. The same data here we have the circle coming like this. Circle coming like this. Okay. Okay. Then draw the diagram, and now you can say what? Point P cannot be found on the circle, so that PR points what? Down. Therefore, in this V less than U case, the unknowns cannot be found. That's how we write in words. Right. Now write down. First draw this circle and we'll write. Write down. There is no position on the circle for the point P, so that PR vector line down direction this way. PR vector line downward, put the arrow. Therefore, when V less than U, the unknowns cannot be found. The unknowns cannot be found. The unknowns cannot be found. Right. Unknowns cannot be found, people. Okay, now in your tutorial, I put the tutorial in the morning, people. First question in the tutorial. Right, we'll come to that. A motor car moves with velocity 30 kilometers per hour due west. A van moves with velocity 60√2 kilometers per hour to southwest. Find the velocity of car relative to van. Very simple question. I'll use this data available in the question. Like this. Question number 1 in the tool. Right? Motor car. I take C. Car. Right? A van. I take people. Hmm? 30 kilometers per hour. Due west. Due west means people this direction, no? West. Northeast, southwest. And the velocity relative to Earth. Van moves 60√2 southwest. North, east, south, west. Then southwest means people between these two, this angle 45. This is southwest direction. This way. This is 45. Now what is asking? Find the velocity of car relative to van. Velocity of car relative to van. This one only we need to find. We have to subject these people by using the principle of relative velocity. Principle of relative velocity, you have to subject this. And both. No. So then in this case, no need to do a circle. What are the occasions we need to draw the circle, people? There are three velocities. One velocity we know in both magnitude and direction. Another velocity only magnitude, another velocity only direction. That case only, people, we have to draw the circle. There are also the velocity which has only direction, we have to subject. Remember that. So then in this case, we can write by the principle of relative velocity. Velocity of car relative to van, we can subject v c comma e. I put here pq vector plus qr vector, and this is pr vector. Like this. Right. Just try, people. Take this. Right, people. We write this way. I substitute for this CE left on 30. But it is given by PQ here, P here, Q here. EV. VE, this direction. Then we interchange this order, the direction gets opposite. 60 root 2, this one. This angle is 45. Then we have to draw, people, the triangle like this. This is 30. PQ, QR. Say 6 root 2. Right? People, now we haven't drawn this lengths of the line segments correctly. Approximate lengths only we have taken. Well, how do you know that the point R, right? When I draw a vertical line now through the point R, the point P is on the right hand side of this vertical line. Sometimes this point R, when I produce like this line, when you draw a vertical line, the point P can be on the left of this vertical line. Well, how do you know correctly the way of the point R lies on the diagram, whether it is on the left of P or right of P, the point R? That can easily be found like this, people. Suppose like this, the point R lies like this on the right of P. P is here now. Then we can find this length. When you drop a perpendicular like this from this R, okay, this length we can find. It is 6 root 2 cos 45. Cos 45, 1 over root 2. These two you can cancel now. This is coming as 60. The length from here to here should be 60. This is 30 now. Therefore, definitely the point R should be lying on the right of P. Right. Just see, people. Point R. Okay. Now what you need to find, people, is PR. PR is the velocity of the car relative to van. PR. Then PR length we have to find. This length only we need to find. And that direction also we need. Right. Well, now in this case, to find this PR, we can use the cosine rule. Cosine rule. What is the cosine rule? When for a triangle in the standard notation? Here A, B, C. This angle is A, this angle is B, this angle is C. This length is A, length is B, length is C. You know what is this? A cos C, outright. B squared plus C squared minus A squared divided by 2BC. Like that, you can write this cos 45. 30 squared plus 60 root 2 perfect squared minus opposite side squared only come in here. Here minus A squared means A means what? The opposite side to the angle A. Right? Then using cosine rule, you can find people this PR length. Use the cosine rule. By cosine rule. You can write PR squared is equal to cos 45. You can write cos 45 is equal to 60 root 2 perfect squared plus 30 perfect squared minus PR squared divided by 2 times 30 into 60 root 2. Okay. This cos 45 people I can write as 1 over root 2, then you can subject PR. Cos 45 1 over root 2. 60 root 2 perfect squared. 30 squared minus PR squared 2 into 30 into 60 root 2. This root 2 and this we can cancel down. This we can use the cross multiplication to descend. 60 and 60 squared come in equals 60 root 2 perfect squared plus 30 squared minus PR squared. Bring this side. PR squared equals 60 root 2 perfect squared plus 30 squared minus 60 squared. Right. You can now simplify furthermore these people. This is now 60 squared into 2 minus 60 squared. This one I wrote plus 30 squared. See what do you get, people? 60 squared into 2 minus 60 squared means 60 squared coming, no? Plus 30 squared. Okay. Well, what is meant by 60 squared? 6 into 10 is the 60. Its square means 6 squared, 10 squared. 30 squared means 3 into 10. Then its perfect squared means 3 squared, 10 squared. It is PR squared. Right? Then you can take this 10 squared out. Then here we get 36, 6 squared plus 9. Then PR, take the square root. Here 10, here 36 plus 9 is 45. Root 45. This 45 you can write as people 9 into 5. 9 into 5. Root of 9 is 3. Then 30 root 5 is the PR. Therefore, PR is 30 root 5 kilometers per hour is the PR. If you need to find the direction, people, the direction can also be found like this. I'll take this angle as alpha. If this is alpha, this is 180 minus alpha. This angle is going to be 180 minus alpha. Right. Then to find this alpha, we can apply sine rule. What is sine rule, people? This length divided by sine of this angle equals this length. Just now we found, no? 30 root 5. This length divided by sine of this angle. Understand? That way you can take the angle alpha, right? Now you can write by sine rule. We can write, people, 60 root 2 divided by sine 180 minus alpha. Equals 30 root 5 divided by sine 45. Sine 45. Okay. Here's a cross multiplication like this. 60 root 2 sine 45 divided by 30 root 5. Sine 180 minus alpha is sine alpha. Take to this side. Sine 45, people, 1 over root 2. That and this we can cancel down. 30 and this 60 we can cancel down. By 30 we get sine alpha as 2 upon root 5. Then alpha is, people, sine inverse 2 upon root 5. Then, people, how to give this direction of this PR with respect to the 4 major directions? Yeah, I'll explain that too. Then shall I erase this part? Yeah. Well, this is the 4 major directions: north, east, south, west is the origin. With this angle alpha. This is 30 root 5. Then, people, how to, this arrow is going out from this center in such a way that we have to mark. Then this direction is known how, people? An angle alpha. Here the angle alpha, when we measure from here, people, from east towards north, no? This angle lies from east towards north. Then the direction is said how? Like this. An angle alpha north of east. This is how we write. An angle alpha north. An angle alpha towards north. An angle alpha towards north here. From where? From east. It is written like this. An angle alpha north of east. That is how we write. What is angle alpha? Angle alpha is given by sine inverse 2/√5. With size with magnitude what, people? 30√5 kilometers per hour. This is the exact direction of the people velocity of this car relative to n. Understand? Right. Then people, today I supposed to come to the end of the lesson here.